experience with the topics. Upon completion of this module, you will be able to do the following: describe the common virtualization trends, explain vSphere's performance transparency, and state user perceptions and answer common questions. The adoption of virtualization has trended through the technology adoption lifecycle similarly to other disruptive technologies. Virtualization began to enter the IT industry at the enterprise level noticeably around 2005. The entry began largely with the virtualization of what might be called Tier 3 workloads. Examples would be print servers, file servers, DNS servers, and web servers. The vast majority of the virtualized servers were Microsoft Windows. Virtualization continued into what might be called Tier 2 workloads. Examples would be production application servers, as well as pretty much all servers hosting the pre-production product lifecycle. That included pre-production relational database servers, and those included Microsoft SQL Server. As early as 2012, the majority of the world's servers were virtual, with VMware accounting for more than 85% of them. It is the rule, not the exception, for the average enterprise to have virtualized between 30 and 60% of its servers. The ratio of Windows to Linux, guest operating systems, is accelerating in the direction of Linux. This trend is especially notable in the Tier 1 workload space. Having progressed this far, many enterprises experienced what has been called VM stall. The average enterprise that has virtualized over 50% of its servers still has yet to bring the benefits of virtualization to its primary Tier 1 production operations and servers. Those Tier 1 servers account for the majority of the enterprise's critical functionality and revenue. SQL Server is one of the top database engines of choice for Tier 1 workloads. Therefore, the status as of early 2012 was that the vast majority of production SQL Server databases had not yet been virtualized. This bell curve, representing the virtualization of SQL Server, demonstrates the opportunity that lies ahead. The opportunity is not one of server counts. Rather, the opportunity lies in virtualization's future impact on the enterprise's most critical operations and the bulk of its revenue. Server consolidation has been a huge benefit as shops have matured through Tier 2 or Tier 3 workload virtualization. Consolidation can still be significant in vSphere-enabled Tier 1, but your consolidation expectations in the Tier 1 space should be more modest. For many workloads, peak processing windows have added to the expense of sizing native hardware. vSphere's workload isolation and automatic load balancing can open the door to SQL Server license optimization. A challenge with native hardware is sizing the stack for peak load, whether that occurs nightly, weekly, monthly, or quarterly. It is not uncommon to encounter stacks during business hours operations with an average of 5 to 15% CPU utilization. That can get expensive, especially where the cost of SQL Server processor-based licensing can overshadow the cost of the rest of the stack. vSphere provides production workload performance guarantees without the need for dedicated hardware. These performance guarantees will be discussed in more detail later in this module. SQL Server's licensing model is hypervisor agnostic. It is dependent on not only how many instances are installed, but also on where these instances are installed. Licenses are purchased either by server or by processor. The level of licensing determines the number of installed instances that are allowed per hypervisor. In a vSphere environment with processor-based licensing, given a physical node on which the SQL Server instances are running, all of that node's physical sockets must be licensed. Many enterprises allow all their SQL Server production and pre-production workloads to float within a vSphere cluster. This method can allow shops to achieve well over 50% CPU utilization sustained on their SQL Server license, a wonderful optimization. It is not unreasonable to target sustained CPU utilization as high as 70% in a Tier 1 SQL Server vSphere cluster. Consolidation ratios of 15 to 30 have been common in the Tier 2 and Tier 3 space. It may be more reasonable with Tier 1 SQL Server workloads to set the consolidation expectation in the range of 100 to 500%. One of the greatest benefits to Tier 1 workloads includes the prospect of approaching 100% disaster recovery reliability. The virtual machine shroud around the production SQL Server database instance node contributes to the achievement of 100% reliable disaster recovery. Fully virtualized, any patches or configuration changes to either the operating system or SQL Server instances are automatically captured, whether by backup or replication technology. This eliminates the need for technicians to manually replicate patches and configuration changes to the standby stack. It also endows the disaster recovery stack with a predictable failover reliability that is difficult, if not impossible, to achieve with native hardware disaster recovery. vSphere can in many cases allow multiple production servers to share a much smaller configuration of standby hardware compared to native hardware disaster recovery. This paradigm even opens the door to quickly selecting from available standby site hardware after the emergency production failover phone call comes in. The benefits to disaster recovery reliability alone are a significant incentive for enterprises to consider virtualizing even dedicated workloads. Tier 1 SQL Server database disaster recovery can be achieved with the combination of vSphere in a handshake with array-based replication. It can be further supplemented with traditional SQL Server Witness Server for an extra layer of disaster recovery insurance. This slide is merely an introduction to the benefits of disaster recovery optimization under VMware. This topic will be discussed later in this course. One of VMware's most tenured and successful tooling initiatives is known as VMware vCloud Director. vCloud Director allows non-technicians to quickly make full clones of live multi-node configurations at the push of a button. vCloud Director allows multiple stacks to enjoy code and data independence while sharing the equivalent of one native hardware stack storage allocation. New clones of the original stack are automatically network fenced. The new stack can be configured with a wide array of networking and security options, including, but not limited to, VLANs, point-to-point, routing with 5-tuple firewall rules, or full network isolation. As such, vCloud Director optimizes all aspects of the release cycle. Enterprises can enjoy radically reduced dependence on hardware provisioning, compressed release calendars, reduced human involvement in a release, more features per release, and a more thorough, effective QA. A more recent addition to the VMware product lineup is vFabric Data Director. vFabric Data Director introduces True Database as a Service, DBaaS, functionality into your organization. vFabric Data Director automates deployment, management, and governance of thousands of databases, and enables policy-based, self-service database management for application developers. vFabric Data Director combines the convenience and ease of use of public cloud database services with the enterprise-grade security, flexibility, control, and compliance required to build your own private and hybrid clouds. vFabric Data Director not only enables DBaaS SQL Server functionality, but can also provide Oracle, vPostgres, and MySQL DBaaS for your private cloud. Native hardware-based workloads can be susceptible to destabilized performance by peer workloads consuming resources on the same box. Development and QA activities largely center on the business day and traditionally have been isolated from production hardware. This separation was necessary to enforce performance isolation and avoid what may be called the noisy neighbor problem. Contention can manifest itself over any or all of a physical server's resources, whether CPU, memory, I/O, or network. Traditionally, hardware-level partitioning could be used to enforce separation of workloads and thus provide performance guarantees. Hardware-level partitioning was available in mainframes and some higher-end RISC Unix models. The adoption of x86 hardware in corporate IT provided the promise of significant savings in capital spending. But mainstream x86 server hardware did not provide the isolation many production workloads needed. Enter vSphere's proven track record of enforcing resource isolation and performance guarantees for prioritized workloads. VMware Distributed Resource Scheduler, or DRS, automatically hot migrates workloads to other hosts well before any performance impact on prioritized workloads. The combination of x86 commodity hardware and DRS equates RISC Unix hardware partitioning for a much smaller spend. VMware vSphere High Availability can provide significant levels of high availability for many workloads. VMware HA does so without the complexity, fragility, or cost of Microsoft failover clusters, commonly referred to as MFC, or Microsoft Cluster Server, MSCS, on older versions of Microsoft Windows. Some workloads do require certain advanced high availability features. A number of SQL Server technologies can be utilized to improve the high availability of a database server. These technologies include the traditional MFC, as well as the new SQL Server 2012 always-on availability groups. The rules for proper MFC server design and software development are much more rigid than those for single-instance workloads. The problem is that it can be expensive and labor-intensive to configure dedicated native hardware MFC stacks throughout the release lifecycle. For this reason, it's not uncommon for code targeted for MFC to get its first shakedown on MFC in the last stack before production. vSphere and SQL Server HA features are complementary technologies. vSphere enables MFC, or always-on deployment, beginning with the first developer's stack, efficiently, inexpensively, and without hardware dependencies. Evaluation criteria for single-instance SQL Server on VMware HA versus advanced SQL Server HA options on VMware HA will be discussed later in this course. One of the better-kept secrets in IT is that vSphere-enabled workloads can be inherently more secure compared to native hardware. This is the case even before considering any of VMware's add-in security components. This benefit summary introduces a handful of reasons. vSphere environments benefit from years of hardware layer security joint engineering with both Intel and AMD. vSphere enforces randomization of executable locations, radically reducing an attacker's ability to predict an effective attack vector. vSphere dynamically translates code at the system level, while limiting the count of instructions per translation unit, thus preempting attacks via buffer overflows. vSphere zeroes all physical memory as it is allocated to a virtual machine, preempting the possibility of memory leaks. vSphere provides complete isolation of host resources between workloads, even to guest-level accounts with operating system administrator privileges. vSphere virtual switches are less vulnerable to MAC spoofing, random frame, and other types of attacks compared to their native hardware counterparts. Finally, security analysts agree that the ultimate way to manage a security threat is through a small attack surface. vSphere 5.1 wins that shootout in spades in comparison to its competition, with its under 150 megabyte hypervisor. When a production problem occurs, create a snapshot to capture an entire multi-node production stack. This allows the error state to be reproduced on demand. That production stack snapshot can then be triaged and diagnosed by internal IT teams or application vendors using secure links. One of the banes of Tier 1 production diagnostics is repeatability. Solving this problem can eliminate a lot of dodging and finger pointing on the part of application vendors. This benefit of Tier 1 production on vSphere is presented last, as it is a forward-looking statement. A quite famous engineering problem is how to snapshot a live multi-node production configuration with no pause. The larger the virtual machine's memory in a configuration, the longer the pause. vSphere engineers have been focused on this for years and are no doubt getting closer to solving the problem. Meanwhile, enterprises can begin project planning for Tier 1 virtualization so they are ready to leverage this benefit. A few concerns about virtualizing Tier 1 SQL Server workloads are more common than others. Although this is not a comprehensive list of all enterprises' concerns, the list represents the most common misconceptions that still persist today. Will Tier 1 SQL Server workloads perform well on vSphere? Is SQL Server on vSphere supported by Microsoft support? If so, is the support limited? Do all nodes in a vSphere cluster have to be licensed if SQL Server only ever runs on a subcluster of nodes? Do very large footprint databases, or VLDBs, present obstacles to vSphere performance or other aspects of virtualization? Resolving these concerns provides an incentive to understand the importance of this course's Tier 1 SQL Server on vSphere best practices. In May of 2008, VMware headed up the first of many significant Tier 1 workload benchmarks on ESX Server. The benchmark was initiated to counter an IT industry perception that VMware must have performance issues with I/O-intensive databases. In preparation for a description of this benchmark, a review of a common performance tuning approach for SQL Server DBAs is appropriate. DBAs are concerned about SQL query access path optimization. They are also concerned about the performance of each of the 4 hardware-level resources: CPU, memory, network, and storage I/O. The DBA works with peer technical administrators to drive performance problems out of each layer of the 4 resources. In this tuning effort, disk I/O is commonly the final and most difficult frontier. The benchmarking team used a 16-core Intel node with 32 gigabytes of RAM. The storage was 3 EMC Clarion SAN cabinets loaded with 15K fiber channel 146 gigabyte drives, for a total of 495 spindles. The benchmark was on an older ESX server release. The team generated I/O load with Iometer, running in Windows 2003 server guests. It used random I/O and an 8K block with 50% reads and 50% writes. That is a radically heavy I/O blend in contrast to most OLTP workloads' read-write ratio, which is closer to 90:10. The team intentionally crippled the SAN's read cache. It stopped cloning with 12 Iometer load virtual machines when it achieved 60% disk saturation. That is more than fair, as 50% average disk busy metric is not an unreasonable trigger to add more drives. At that point, the team measured 102,000 I/Os per second. The SAN measured the I/O round trip at about 6 milliseconds, unchanged as the I/O load scaled. The I/O virtualization latency wedge was identified by subtracting the aggregated guessed Windows Performance Monitor disk metric from the Clarion metric. The latency was a whopping 1.4%. The actual ESX server scalability ceiling remained unknown, as no more loaner Clarion cabinets were available for the benchmark. The ESX server configuration was pretty much straight out of the box. 102,000 IOPS is enough I/O throughput to handle 200,000 moderately busy Microsoft Exchange mailboxes. That equates to the I/O of 75 to 150 moderately loaded 4-way production OLTP databases. All that was accomplished on an ESX server release quite aged compared to what is available today. About a year later, VMware did an overall throughput study on vSphere 4.0. The workload's Oracle database was hosted on an Intel Xeon 5500 2-socket server. The benchmark was based on a fair use implementation of the TPCC workload specification. However, the results were not audited, and as such cannot be declared TPCC compliant. This workload demonstrated 60,000 IOPS and 8,900 database transactions per second. The workload achieved 85% of native transaction throughput. Arguably, the TPCC OLTP benchmark is more resource-intensive per transaction than the vast majority of production workloads. You can get the full details on SQL Server performance benchmarks by clicking the link shown on your screen. For customers with Microsoft's Enterprise Edition licensing for both Windows and SQL Server, the licensing options are relatively straightforward. License all of the sockets in the vSphere hosts, add software assurance for virtual machine mobility, and the customer is allowed to run an unlimited number of virtual machines without additional licenses. Leveraging this licensing model, vSphere can enable consolidation of multiple workloads into a single host. In many cases, customers can use vSphere to achieve substantial savings in their enterprise-based SQL Server licensing. A customer may not have enough instances of SQL Server to justify a dedicated vSphere cluster. In this situation, only a subset of the cluster's hosts is licensed for SQL Server. Because customers are typically able to increase the utilization of licensed processors, they reduce SQL Server license requirements. However, lower consolidation may result, because advanced vSphere features are employed on only a subset of the hosts. Microsoft's support statement for VMware has been visible for years. Microsoft joined the Server Virtualization Validation Program, SVVP, in August 2008, and all of their applications and operating systems are officially supported on VMware-based virtualization environments. Even before Microsoft joined SVVP, Microsoft Premier Support customers had been able to take advantage of virtualization benefits. Even today, Premier customers continue to play by a different set of rules and are not typically bound by any restrictions that may be present in SVVP. For customers who are not Premier, SVVP was created to provide mainstream support for virtualization of Tier 1 Microsoft applications. Note: Microsoft Support reserves the right to ask customers to prove that new issues attributed to SQL Server are not a result of an application being virtualized. To answer that question, published Knowledge Base Article 897615 reserves Microsoft Support the right to ask the customer to reproduce the problem on native hardware. VMware says, fair enough, this is essentially the same as every other ISV to one degree or another. The key is to look at the history of Microsoft Support with regard to new issues. Gartner, IDC, and others also have documents for their subscribers, which specifically address SQL Server's support policy for VMware. Many customers have enjoyed best efforts SQL Server support for years. This includes when the customer is fully disclosed as running on VMware. It also includes occasionally when a bug or issue is encountered that is not in Microsoft's knowledge base. VMware routinely asks reference customers globally to share their successes in getting appropriate and helpful responses to Microsoft support requests. VMware's Global Support Services, or GSS, is also available to coordinate support requests directly with Microsoft Support. VMware GSS brings the added benefit of collaboration with Microsoft Support, to which both organizations are bound under the terms of TSA-NET. A common misconception is that the size of the database somehow relates to performance on VMware. It does not. The database attributes that impact performance are largely the same whether the database is on native hardware or virtualized. Examples are attributes such as execution counts, concurrent connections, and SQL access paths. Whether virtual or native, database size does have an impact on the throughput of backup recovery times, disaster recovery operations. This concludes the Introduction to SQL Server Database Virtualization module. In this module, you reviewed Virtualization Trends. You learned about vSphere's performance transparency. You learned about customer perceptions and the answers to common questions. Now that you have completed this module, feel free to review it until you are ready to start the next module. When you are ready to proceed, close this browser window to return to the course contents page.